Good evening, everyone. Today, we are going to start with session 34 of Python and Data Analytics Internship Program, October 2025. Today's topic that we are going to cover is Introduction to Machine Learning Concepts. So, machine learning is a later part of data analytics. It is very important to know that what machine learning is, what are different types of machine learning, because these techniques are used to build the models at the end. That is your prediction models. Okay, so the models that basically interact with you based upon the user data are built using machine learning only. So the objective in today's session will be as follows. Like in this session, we will know about the fundamental ideas of machine learning, what machine learning is, and it's a brief overview about it. Okay, by focusing on what machine learning really means, why machine learning is needed in today's world, different types of machine learning, and how much learning models learn from data. So we will cover all these topics in this session only. And this session is about understanding concepts, not complex math or coding. So we are not going to cover any math fundamentals or any coding part through these examples. Okay, any coding examples. So it is basically a theory class, so that you have knowledge about machine learning, and later on we will see about those techniques in the upcoming sessions. So what is machine learning? Machine learning basically is a branch of artificial intelligence that allows system to learn pattern from data, improve performance over time, make predictions or decisions, work with without being explicitly programmed for every rule. So let's understand first that what machine learning really means. You all have heard the term artificial intelligence, that is AI. You can see that AI is ruling the world in today's scenario. Okay, everybody is focused on AI, but AI is itself not a single field. It consists of many subfields inside it, and one of those subfield is after this comes deep learning that we are going to cover in this internship program. Uh, Machine learning is a part of artificial intelligence. You can consider artificial intelligence as a copy or to mimic human intelligence, so that can behave as a human. We are yourself as a human predict many things in everyday life. Like you are jumping from one stair to other stair, or you are jumping over a hole or some object that is in front of you. So there your brain is analyzing all the data. Okay, this much height is, you don't know the exact height, but in your brain there are certain assumptions that are being created from the data that you are seeing through your eyes. Consider your eyes as the camera, CCTV camera. So that data is being fed to your brain, and your brain is coming up with the prediction or decisions that you make, like, okay, will I be able to jump this much distance or not? If not, I should take another route. If I am able to jump from one if I am able to cover this much distance in one jump, then I will jump. So this is kind of predictions. Similarly, we are creating that part of ML only, that is machine learning. We are making the machine, basically machine, consider machine as a student who doesn't have any knowledge, and you are teaching that machine, okay, this is what this data means. These are certain patterns. Okay. Now, based on those patterns and data, you have to make certain predictions or decisions. Okay. And we are not going to program it. Like, we are not writing a whole program to predict every decisions of yours. We are simply creating a model which is able to predict any future scenario for which you are creating it without being programmed explicitly. Like, you are not programming it again and again if a new data comes. So what is happening behind the scene is that you have the data, the process data. Now, with the help of that data, you are creating a model. Consider model as a machine which you are training. Okay. Now you have trained that machine based on the, for example, based on the patient's data. Like, you have gathered the patient details from all the hospitals all over India or all over world. Okay, this is the age of patient, and this patient is suffering from asthma. You take another patient or another patient, then that data is being aggregated. Certain patterns and predictions are being generated, like patients that are living in Delhi, persons that are living in Delhi are having more patients as asthma patients as compared to patients living in Guwahati, that is in Assam. Okay. So now there comes the prediction. Like, after that, once the model is created using that data, you have taught the machine, okay, these are the things. Itne patients are coming from Delhi, itne are coming from Guwahati, and this is their age, this is their gender, etc. Okay. So now machine has come up with certain assumptions and patterns on its own that the machine has learned through the data. Now, suppose a new patient come or a new person come which is not diagnosed with asthma yet. Now you want to know what are the chances of that particular person to suffer from asthma. So you will fill in the details of that person to that model. Okay, my name is ABC. I am living in Delhi. My age is 34, and some certain other parameters that you want. After that, once the data is being fed to the model, based upon the historic patterns that he has learned from the data during the training, will come up with the predictions and assumptions. Okay, if you are living in Delhi and you are 34-year-old, so you have almost 90% chances of suffering asthma till you reach the age of 48. Okay, till the age of 35 you have uh, chances of getting suffered from asthma approximately 20% or 25%. I'm not telling you that these are the only specific number. The model will tell those numbers based on the age, gender, and the place they are living in, because the model knows there might be certain factors that are affecting the people living in Delhi more as compared to the people living in Guwahati. So the chances of suffering asthma for a person living in Delhi are more as compared to the person living in Guwahati. So you are not programming anything here again. You are simply allowing the model to predict the future of that person. That future might not be 100% correct. 100% accuracy is nearly impossible to achieve. But that model prediction can be correct up to 90%, 95%, 98% based upon the amount of data that you have used during its training. So this is what machine learning is. Real world examples are like spam mail email detection. Okay. So like you have a data set of thousands and thousands of emails with you. Using that data set, you have created a model. which is intelligent enough to categorize the mails as that they are spam or not. You have also seen like there is a feature on your phone now. Whenever a call comes from unknown number, then if it is a potential spam or a business call, then it is highlighted as spam or spam call on your display screen. So how it is being done? There is no person is sitting there and analyzing each and every mail and each and every number. So based upon the data that they have created some types of models or some types of program, they are predicting, okay, this phone number is getting reported many times, so this might be a potential threat to the customer or the consumer. Similar models can be made for emails. Netflix, Amazon recommendations. You have also seen that you started watching a movie from the like you started watching Hollywood movies on Netflix instead of Bollywood movies or Bollywood web series. Similarly on Amazon platform. So what you will get in the recommendations will be, after watching it, you will get more and more recommendation from Hollywood category instead of Bollywood category. If you are watching a comedy movie, then you will get receiving recommendations of a comedy movie. Okay. Similar thing happens during your during when you visit Flipkart, na, you go there and you search about a product. Okay, I want to buy uh, 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 basically a sneaker. Okay, a sneaker shoes I want to buy. So you are searching on Flipkart. But as soon as you come out of the Flipkart and open your Instagram or any other social media platform, you will start seeing ads of different sneaker shoes. Okay, these are the sneaker shoes with this much sale going on, and yeah. So how the Instagram is getting informed about your decision that you are making on Flipkart? It is basically machine learning there. They are utilizing your patterns. Okay, they are saying, okay, customer is seeing this product, the information, that data is being shared to other things also, and the ads that are basically published through Flipkart on the Instagram or sellers on the Instagram. So you start getting suggestions regarding that particular product. So all these things happen due to machine learning only. No individual is sitting there and watching your behavior. Machine is watching your behavior, and based on your patterns, based on your desires, they are recommending you the product. A person is searching the e-commerce platform to buy shoes, then it is very highly likely that that person is in need of shoes and he will buy it. That buying accuracy increases to 80%, 90%, sometimes 100% or 99%. Okay, so this is how you are being manipulated through these technologies nowadays also. Credit card fraud detection. Okay, these all things happen. Machine learning models means they help you get things resolved. They behave like someone is supervising everything for you. So now we have understood what machine learning is, but why there is a need to learn machine learning. Okay, so traditional programming struggles when rules are too complex, data is large and constantly changing. This is what the whole meaning behind machine learning is. Okay, so earlier what was happening, if I tell you in simple words, there were certain rule based programming. Rule based programming is like that: if the customer is behaving in those set of rules, under those set of rules that are set by the programmer, the program is able to detect, okay, this is what the customer wants. That is like the chatbots are made earlier. Like if a customer sends hello, then the chatbot should say hello or hi with with your name. high ABC. Okay, so they were using rule based programming, but the problem came when the internet revolution arrived at a very fast space, and the smartphones become very common in everybody hands. So what was happening is that large amounts of data keep coming on okay, and then the customer behavior is not under those set of rules that the programmer has applied earlier. The customer behavior was continuously changing, their demands were continuously changing. So the rule based programming was not able to handle that large amount of diverse data. That's when machine learning comes in picture. So machine learning is not a rule based programming. That model is your mini brain. It's behaving like a mini brain. If a customer behaves in a different way that is not expected from the customer, the model is able to detect that also. Okay, model might have find some patterns for these unpredictable behaviors of the customer, and then model can behave according to their needs. So the rule based programming limitations were overcome by using machine learning. And even if the data is large and constantly changing, we don't need to worry about it, because the large amount of data we have and the diverse amount of data we have, our model will become more and more smart with the data that it receives. Okay, it's like a in earlier stage, the model is like a child's brain. Okay, it is learning, you have taught him something and it is behaving to according to that training that it has done. Now as more amount of data comes and is being fed it to the model again and again, the model is being trained and again, like you have seen the chat gpt comes earlier like chat gpt 3, then it became chat gpt 4, now it is 5.2. Okay, so the versions are coming. What these versions symbolizes, like the latest model is more powerful and smart than the earlier models. So when the chat gpt 3 model was trained, that data was different. Suppose they have trained that model with 5 billion parameters of data. Now since users started using it, many different things came. Sometimes the chat gpt 3 gave the wrong answer, so user was giving feedback, okay, your answer is wrong, this is not what I want, I actually want this type of answer. So that data is being fed again, that data is being stored somewhere else. Then using that data also above the 5 million parameter, they trained a new smarter version, that is chat gpt 4. After that, when more amount of data comes, then they trained chat gpt 5.2. So the model keeps evolving from a child's brain to a adult's brain, and then to a very experienced and professional one. Okay, so earlier rule based programming start breaking when data is changing or data is large. Okay, but when the data is large and constantly changing, instead of breaking down, our models are getting improved. So it's a plus point, they are behaving like a human brain there. Okay, so the predictions and the assumptions that we will be receiving from the models will be more accurate as compared to earlier. Their accuracy keeps on increasing and increasing and increasing. Since we are not able to mimic human brain 100%, so accuracy is always less than 100%. So machine learning helps by enabling pattern discovery from large data sets, predictive decision making. Okay, like when you need to discover patterns from large data set, then you need to use basically machine learning thing. Predictive decision making that we are talking earlier, like what are the chances of person living in delhi of age so and so getting diagnosed with asthma. So that comes in under predictive decision making. Automation of repetitive task. Okay, there are certain tasks that are repeated on daily basis, then they can be automated using machine learning. Scalability with growing data that I told you right now. The more data that grows, so it can expand itself according to that data. The newer version will get upgraded with more smart behavior as compared to the older versions. Personalized user experience that I told you about, Flipkart thing. Okay, like you are seeing shoes on Flipkart, then you start receiving ads of shoes on other advertising platforms like Instagram, Facebook, YouTube, etc., where the ads comes. So what they are doing is that they are gathering your data. Okay, you are interested in this thing, and then personalizing the ads according to your needs. It's not like that you are searching for shoes and you started getting ads of clothes. Okay, you will see the ads of shoes only many times on the social media platforms. If you want, you can test it today also. You start searching about a product on Amazon and Flipkart, and the more amount you search, the more amount of ads you will start receiving. That is being done by using machine learning only. So ML helps systems become smarter as the data grows. That I told you. The more amount of data they receive, the more accurate their predictions and decisions start becoming. So there are many types of machine learning, but broadly it is categorized under these two only. There are different algorithms. Okay, there are reinforcement learning, linear regression, many other algorithms, but all those things are basically categorized under these two only, like supervised learning and one is unsupervised learning. So when the data has input and correct output, data has no predefined output. We will talk this in detail in the upcoming slides. Other types that we will not be covering today are semi-supervised learning and reinforcement learning that I told you, right? So we will be focusing on supervised and unsupervised learning. Supervised learning means learning from labeled data. What is labeled data? Is that you have a data that is basically labeled properly with the particular fields and columns with their particular names like salary, age, customer name. So there are those are labeled data. So input features we consider on the x-axis and correct output will be on y as y. So examples are like predicting house prices or classifying spam versus non-spam emails, predicting exam marks. So like you have a house price. So how will you predict house price? Let's think about it. Okay. So you will see what you will see is that, okay, your model is basically what your model will be using is that you will see in which particular area what is the demand of land, what is the price of land per square meter there. Okay, and if that land is on a very good location, then its price get increased according to that only. Okay, now you have to also see that what will be the cost of making the house in that particular area, what is the cost of raw materials, or okay, what is the cost of labor there. So by adding all those costs, the total cost of house comes in that particular area. Now you want to know about the cost of the house. You will feed, okay, this much square meter is the land that I will be needing, and uh, uh, then you define some certain parameters. This is the area. Yeah, you give the details to the model. So model is trained on the earlier data, a large amount of set of data. So model will come up with its own suggestion. Okay, if you bought the house today, then this will be the price of this house. Now you want to know if I will buy it after 10 years, well, what will be its price? So model will tell you, okay, after 10 years, we have seen that in the past years, it is increasing at this much pace or speed. Now after 10 years, your house prices might be lying around this particular range according to the inflation. So these things are being utilized in supervised learning, but you will see that the data is labeled there. There are house prices, there are land prices, there are raw material prices. Certain type of costs are labeled in their particular columns. Similarly, classifying spam versus non-spam mails, we use supervised learning, predicting exam marks. So these things are labeled. Basically, you need a labeled data for it. Common algorithms for this is these are linear regression, logistic regression, decision trees, support vector machines. So we will cover these later on, but these are some algorithms that are used under supervised learning. Give me a second. So now let's move to unsupervised learning. So unsupervised learning basically means like learning from the data that is not labeled. Okay, like we don't know the answers. Here we know what inputs we are giving, what outputs we are getting. But in unsupervised learning, that we consider it like data without knowing the answers. Okay, so imagine if for example, I give you a classroom full of students, but in that I am not telling you anything about them. Okay, I am giving you the data, but I am not telling anything about the students. So there, you what you can do, if you think logically, we can group the students by their heights or by their dressing style. Okay, yeah, girls dressing style is this, boys is this. So we will make them apart from each other using their dressing styles. Or what we can do, we can even use their behavior, like okay, these students like sports, these students like to study, okay, these students like to do work on computer, etc. So based upon their behavior, we can basically categorize them. So no labels are given. You were only given a classroom that is full of students, but you were not told, okay, this is boy, this is a boy, this is a girl, or this is the interest of this student. But we will create our own labels there. So no labels will be given. You discover groups by observing the patterns. Okay, like we have observed in between girls and boys. Okay, in this in particular school, girls are wearing skirts, or boys are wearing pants. So the dressing style of boys is very different from the dressing styles of the girls. Girls are having long hairs, boys are having short hairs. ठीक है. So we are basically creating our own labels there by observing the patterns inside the data. In earlier supervised learning, we were already given the labels. The data is categorized. Okay, this column consists of housing price, this column consists of land price. But here you were given a class of students where you don't know about the students. So in order to make model learn from that data, you need to categorize that data. And that data can be categorized by analyzing the patterns hidden inside the data. Those are not given to you, they are hidden behind the data. You will find out those patterns behind the data that are hidden. And don't worry, it's no it you will not be doing it manually. There are certain algorithms already developed for it. You will run those and they will be able to find the patterns. Okay, so the goal is to discover hidden patterns inside the data, group similar data points, like we are grouping student based upon their dressing sense or by their height. Okay, so group those similar data points in one particular group the girls in other group. So it reduces the complexity. Now the data is divided and our model can analyze that data very perfectly. So if in a very simple definition, if I can say, is that in unsupervised learning, the data has no labels. Okay, and the model finds pattern on its own. It's the responsibility of the model, not yours. Examples are like customer segmentation, anomaly detection. Anomaly detection is like the behavior that you have not expected. I have used this word many, many times. Like you were expecting a surge in your sales during the upcoming quarter, since your sales are getting boosted from the last 3 4 quarters. So your product is performing well, the sales are getting increased, but suddenly you saw a dip in your sales. That is an anomaly. That was not expected behavior. When the prediction deviates from the expected behavior, then it is called an anomaly. And anomaly detection is used by using unsupervised learning, because unsupervised learning works totally upon the patterns that are hidden behind the data. Okay, so we use their anomaly detection, market based analysis like stock marketing. There is, you are not training based upon the certain labels or things and etc. It has to find patterns from the data. Okay, this is how the graph was going earlier. Suddenly the graph was going down. In months of this, the graph started boosting. So the stock prices of a particular stock get increased during this tenure. So it will identify the patterns on its own without your intervention. Okay. So common algorithms that we use are basically like k-means clustering. These are the names of algorithms. You don't need to worry about the concepts hidden behind those, but these are used during unsupervised learning, like k-means clustering, hierarchical clustering, principal component analysis, that we call PCA. Okay. Now let's see the difference between supervised and unsupervised learning. If we see through the aspect of data, then supervised learning is labeled and unsupervised learning is unlabeled. The goal is that it predicts the outcome, means it basically it predicts the output, like you are predicting what are the chances of person getting asthma. Okay, but unsupervised learning is used to find patterns, not for prediction. Although we are going to generate some prediction and results at the end, but it works upon the patterns. It find patterns. Okay, like in stock market, everything in the stock market is about patterns only. So it works upon the patterns and it predicts the outcomes. So output will be known in supervised learning. You know what the output will be coming, or in what format the output will be coming, but in unsupervised learning, it is unknown. The output can be different from what you were expecting, like in anomaly detection. So some common examples or of algorithm that we use in supervised learning are regression and classification, and unsupervised learning are clustering and PCA. Evaluation, basically they tell you about the accuracy and error, and in supervised learning is used to find patterns, and that can be seen through visuals. So choice depends on whether the output labels are available. Okay, then you will apply a particular technique there. So if in simple words you can say supervised learning has a teacher and unsupervised learning has no teacher. It is learning on its own, as its name suggests. So machine learning model, if we look on the machine learning model life cycle, it looks like as follows. Like a typical ML project follows these steps. Problem definition. First, the definition is defined. Then the data is being collected. If you have gone through other earlier lectures properly, you will find that these step resembles very close to data analytics life cycle step that we have told you earlier. Okay. So then data is collected, then data is cleaned and prepared. Then that data is trained, test, split. We split that data into two parts. One part will be a training part that we will be using to uh, that we will be using our model to train. Okay, we will teach our model, okay, this is the data that you need to utilize. And suppose you are having 100 set of columns, okay, and that 100 set of columns, you will divide it into two parts in a ratio that we generally consider as 80-20 ratio, or you can use 70-30 ratio. Means 80% data from that 100 column, 100 fields of that 80 fields you will be using for training. Then the remaining 20 that you have preserved, you will test the model after the training whether the results are coming as expected or not, whether it is able to perform accurately or not. If not, how much error is coming, how much deviation is there from the original result. You will calculate the error there. Using that, you will calculate the accuracy of the model. Okay. So the train test split is done after the data is clean. That we usually do 80-20 ratio, like 80% for training and 20% for testing. Then model training is being done. After that, model evaluation means we will be using that test data, that is 20% data, in order to evaluate our model. How much is its accuracy, how much is error there, okay, how much good results we are receiving, etc. Then after the model is evaluated and tested and seen that okay, the model prediction is good enough, then we deploy that model and start using it. Okay. So these are some examples like supervised learning, hours studies, marks obtained. Okay, you have a data set with you on which you have how much hours a particular student is studying. Based upon those hours, how are the results of that particular student. Then after that, once your model is trained, you input the data. Okay, I am studying for 2 hours a day. What will be my result, predict my result in the upcoming semester. Then it will tell you, okay, you might be getting this much marks if you are studying only 2 hours. If you are studying 5 hours, then your what we call result is getting improved. Okay, there we will be using linear regression algorithm. Unsupervised learning examples like customer age and spending behavior. So output is unknown. Model groups the customers based upon their behavior and age. We use here clustering algorithm, that is k-means clustering. Okay. Algorithm part we will study later. Summary and takeaways from today's sessions are as follows. Like machine learning enables system to learn from the data. We have seen it. Supervised learning uses label data. Unsupervised learning finds hidden patterns. And ML follows a structured life cycle that we have shown in seen in the earlier slide. This session builds the base for regression classification clustering that we will be seeing in upcoming sessions. As I told you, we will be going through these algorithms later on. Today's session is for the overview to get you a basic understanding of what machine learning is, what unsupervised learning is, what supervised learning is. Okay. So understanding the concept is more important than memorizing algorithms. So first, we have gone through all those concepts in today's session, and then we will be moving to the algorithms in the upcoming session. So assignment for you for today's session will be like for supervised task, create a list. First, hours studied and marks obtained. You can create two lists basically using generative AI tools also. Then plot them using a scatter plot that we have seen in Matplotlib sessions. Write a short paragraph explaining why linear regression is suitable for this data set. Based upon your understanding, you can write whatever you want. It is not like you will have to write the correct answer since we have not gone through linear regression. Create a data set with age and spending score. Okay. Plot points on a scatter plot. Visually identify how many natural clusters you see. Cluster means how much grouping you are seeing. Some points will be lying in one group, some points will be lying in another group, some points will be individuals. So you will see where the density is more. Only you have to identify those things. Okay. And if you want, you can write something about that also. But first you will see, okay, in this group, many of the points are basically lying. So that is identifying like okay, this has identified a pattern. If the pattern is according to this, then it will lie in, the point will lie in this particular code. Then you can submit it on the Google form. For help and support, please contact us here. And thank you for joining today's session.